Hello, everyone. We are very happy to be here with you today. It's an optional webinar, a new one, because sadly, Joel Falco couldn't be there to talk about CUDA and cycle. So yesterday we offered the opportunity to change this webinar and to give you the access, direct access to us and Pierre Aubert, of course, to talk about Grace Scott School. We're starting in less than 5 days now, and to talk about the program, the courses, for example, the containers, and most important is we want to answer all of your questions. So don't hesitate to ask questions. Just for your information, we have actually for now 14 satellite sites with us. We are very happy to have them with us. They're great partners in Belgium, in Germany, in Luxembourg, in Slovenia, and too in Netherlands and in France. We have several one in France too. So, and also, sorry, I was forgetting Morocco and Senegal. So 14 satellite sites who are organizing this Grey Scout School with us. We're starting next Monday for 2 weeks. We have more than 500 registrations for now. So we are very happy to welcome everyone. And of course, don't forget that people can join us for the courses they want to attend. It's not mandatory to attend 2 full weeks, but obviously it's open for everyone. So I will give the floor to Pierre Aubert now, who will make a little introduction and talk about the program and all the accesses of the courses and the containers. And please don't hesitate to ask your questions. We are here for you. So thank you and welcome, Pierre.
Okay, thank you, Mary, for the presentation. So, yeah, as you said, yeah, Joel unfortunately cannot join today. So I will take the opportunity to answer to all your questions. And if you have questions regarding the school, of course, you can ask Karine and Marie. And if you have questions regarding the lectures, containers, how to use them, stuff like that, we'll see that together. If I can share my screen, of course. The gag of the day. Okay. It should work. So if you jump, for example, on CCFR here, you can jump on the program here. And then you go here. And maybe, of course, if you have some question, you can ask them in the chat or in the Q&A section. And I will speak until you get some question. So once you jump on this page, you can have access to all the webinars. So this is the last one. And you get also all the program of the school. So we start next Monday at 2 p.m. And the idea is to have basically introduction of what is the Grayscott reaction, how to develop it, what is CPU architectures, vectorization, what is compilation. And the point of all the days is to have a day full on theory or on one or several technologies, so C++, Fortran, SQL, Rust, Python, etc. And the last schedule of each day is about a webinar, a kind of seminar. Here it's a seminar, but it will be a webinar for you because if you follow online, and we will have webinar on unit testing because it's important to have a maintainable program once you develop it. Profiling for memory, it's a bit specific also. Precision, the next step of the presentation of Vincent and Adrien. The impact of the system on application and performance, and then The second week we have GPU, not for the Monday morning because we will have some Eve and Kiwaku lecture from Joel. And then we have GPU, so how to use the GPU, how to use them, so how to compute with NVC++, with CUDA, with stuff like this. And then a little story about qubit square root optimization that we did with Vincent. So how to show you the story, how to find the problem, to optimize it, to dig with all the stuff with Macao, with profiling, to get the information and to find out what to do. Then SQL and Fortran on GPU with a small webinar on Cocos, and then Rust with Vulkan. Julia also as a seminar, and then Python for the last day of the school and a closing presentation and a bootstrap for people joining in ANSI. And we will have the full day, so you can leave at noon if you want, if you have a train to take or something like that. But we have the full day reserved in the auditorium. So if you have plenty of questions or you plan to leave maybe on Saturday or maybe at night or late in this day, you can also stay in ANSI, but this is specific for ANSI. The same for the Saturday here. This is specific for ANSI, so we'll have a little hands-on done by Sébastien. So if you already know what we did last year, normally this will be really interesting. And then question for the teacher. So the point is to have all the teacher on the stage, and then you ask us questions so for everything you want, and we do our best to answer. So for maybe no. Oh, hello, Adrien.
Yeah. Hello. Somehow something happened and it momentarily cut my audio connection. I have no idea.
Okay. So if you have something to add.
Yeah, I just said that because Karim was saying if you have trouble with containers, this is your chance to fix it with Pierre. That's true. However, since containers are designed by individual course authors, some of the issues you may want to bring up to individual course authors if you can.
Yeah, no, normally everything is practically okay, but you should have maybe some trouble if you have, I don't know, some OS that we don't foresee or some configuration that we do not use. This is the first time also we did some containers for ARM, so that's we can have some trouble with that also. It's possible. And yeah, speaking of container, it's a really good transition, Adrien. So here you have all the list of all the containers that you can use for the school. So of course you don't have to use all of them. For most of courses you have 3 containers, so a really light image. Specifically, if you want really you don't have much spaces on your laptop or on a server that you want to use, or if you want typically to be able to schedule a job with Slurm or HTCondor, for example, it's better to use this kind of small images. And then you have the code server images that I can do a little demo if you want with this one. So this is much more designed for laptops. So the idea is to have your container, but if you start the container, you can jump directly in a VS Code inside your favorite browser, and you have everything installed. You don't have to worry about the dependency, and you can play directly with the lecture. And it's compatible normally with Aptainer, with Docker, and with Podman. And we have the last one on JupyterOps, so it's for Kubernetes or Docker Swarm or stuff like this. And typically, what we can get in the Jupyter Hub on Kubernetes that we have on Must. So we have this kind of interface. You have Grayscott Reloaded from last year, so with all the lecture, but in French, of course, and not updated because we have the new version in 2025, and you have not all the lectures, but because they are not all compatible with this platform, specifically because we do not have GPUs on this platform for now, so it's only for CPU courses. But you can have some compiler optimization, which is not really a lecture. It's just to give you some example of what I will present in next Monday about compilation and compilers and passes and all the stuff that a compiler should do, and it's not really trivial. So you have plenty of example to play with if you want to play with that. The C++ Fortran memory profiling and CPU lecture are available also here. Not sure if other will be available, but normally it's not quite complex to get. And if I pick one and I start my pod, so on Kubernetes, now I should be loaded at some point. Yeah, come on. Okay. And so here, so of course I did some tests before, so I have lots of stuff here. So you jump directly in the example directory. So with your name. So if you are, of course, registered in the lab, so you can have the same stuff in maybe in the Maison la Simulation. Maybe there is also some stuff like this, and you have a README, and on this README you can have some information how to get the lecture. So for example, if I click here, I jump directly in the lecture. So you can have everything. So it's a really long lecture, of course, but the point is not to do everything in detail, but you have the detail if in case you have some question. And then you have all the example here, and you can maybe do something like this. I go in the build directory, I compile all the stuff, and maybe I'm alone on the. Oh yeah, it's fine. So of course we'll be not able to do that next week, because we will be several to be connected at the same time. So we will have part of all these nodes. But here I can compile everything, and maybe I can start the unit test here, because we have unit test also. You will see next week why we had unit test, especially with the presentation we will do with Sebastian with the advanced blocking method. You will see what's going on here. And then I can do something like this. Make plot all, but of course it's better with one core, but I will use everyone to have something really fast. So here I start all the performance tests. So of course the result will be not as good as we can expect, but this is just for demonstration. So you see that everything is running normally. I hope 79, 80% common. So the cluster may disagree at some point, but normally it should be okay. And the point is also Kubernetes will split everything. So if someone connects on the fly, you will have less cores, because you split the number of cores for each users. And of course we have in this lecture especially, I have a lot of tests, because the idea is not to make you really develop, but to make you play with an existing program to find out which is the best size of the problem to have the best performance and stuff like that. So you can use a tool to find the information with a foreign program, if you want, which happened a lot of time, especially even if you are the only developer of a small team. 6 months later, you are a stranger for your code, so it's better to have this kind of approach. Okay, and here, so I can get my build directory. In my build directory, I have my performances directory, and then normally if I double click here or one click here, so I get all my performances with the number of elements increasing with the time in cycle. So if I increase the number of elements, of course I increase the computing time, and then here if I divide by the number of elements, I get some plateau here. So there is no much optimization here, because it's O2, O3, and O fast. So partial vectorization, but not too much. And if I get an interesting, or I don't know, maybe this one. No, it was not loaded yet. The demo effect. No, come on. Okay, this one and this one. Okay, need time. So it's auto vectorization, so it's not that okay. And I start also all the tests at the same time, but you have all the tests here. You can play with them, and you can also, of course, jump inside the code. For example, if I want, I don't know, to compute to get to my data layout, for example, here. So you have a lot of tests with the data layout because you will see that it's really important. You can also maybe do some image plotting if you want. So yeah, Adrien will present that to you also. We will not do much, put much accent in the real-time viewer because the point is to have something generic. So of course, if you can do it, it's fine. But the point is to give you some tools to manage big simulation. And once you have one computation ready for 1 minute or for 1 hour, there is no point of having something real time for visualizing stuff. So maybe it will come for next year because it should be fun to do something like that, but it's not the point. But of course, Adrien did a great job on that, so you will be glad to have this kind of stuff. But it's not the main point of the school.
And it's also much harder to do in C++.
And it's also much harder to do in C++, especially if you want to do some Vulkan and you don't want to lose your mental health, but it's fun. Once you manage to do that, it's fun. But yeah, it's... And of course, yeah, we will talk about, as Adrien mentioned also in his webinar, we will talk about here in parameters. So I will give you some hints on how to parse parameters that you pass to your programs, because of course you don't want to use the ugly parameter 1, 2, 3 that you can have in all the programming language. Of course, you want to use a library for that. So in Rust, you can do that. It's really simple. In C++, you can also do that. So I will present you a little library to do that also. So this is not the main point of the lecture, of course, but this is some side part that it's nice to have, because of course you don't want to struggle with this kind of stuff because it's not your job. You just want to pass argument and that's it. So that's a good point for the parameter. The same for the layout. Here I will do the presentation in detail on Tuesday to explain you the idea behind all these examples, because you have several milestones in this lecture. So to be sure that everything is clear. And maybe there is a lot of questions. I have another demonstration on my laptop if you want, but okay. Oh yeah, question from Tom. Is there any prerequisites for the different courses? We already had them for cycle, but what about the other courses? That's a really good question because we forget to talk about that in the other webinar. So basically, if I remember well, for Python, it will be quite an intermediate level. So you should know already some Python, even if they will start. Alice, Jean-Marc, and Nabil will start with a really small part. But if you know already how to develop a bit in Python, how you know a bit of NumPy, you know that it exists and that you can do some math with it, normally should be okay. Of course, they will use much more advanced stuff at the end of the lecture, but normally you will not get lost. For Adrien, I think you start practically from the beginning because you introduce Rust from the very beginning. I
kind of assume that people have some basic familiarity with C-like language, so C or C++ or that sort of things. It does not need to be, you do not need to be an expert in those languages, but you need to know the basic data types, expressions, operators, so that stuff makes sense in Rust as well, because I, for example, do not explain what a modulo is,
Yeah, you know what a modulo is, you know how to define a function, you know how to use a parameter, you know how to define a variable, stuff like this. But if you know how to do a for loop on an if in C++, you will not get lost in Rust.
Exactly.
Yeah, it's really nice to follow your lecture. So yeah, you are taken by hand and you do the stuff step by step, and then you do crazy stuff at the end. But that's for the end. For C++, I start from practically zero, but I assume that you will not struggle too much with builders like CMake, for example. So I'm pretty sure that many of you know how to use CMake. If you don't, I can give you some overview. You will see it's really simple. I don't do crazy stuff with CMake in my lecture. That's the point. It's to have something really simple to use. But the point is to hide from you all the stuff to practically do automatically the micro benchmarking, stuff like this, because it's not the purpose of the lecture. Of course, everything's documented in the lecture. So if you want to know more and to know how I develop everything, you have all the information. But I assume that typically in this command line, you know to create a build directory, to jump in it, and to do a cmake dot to start the cmake, and then you do make, and that's working. Normally, if you know how to do that, will not struggle to follow the lecture, because everything is about how to play with the example and how to criticize the results. So normally should be quite straightforward. For Fortran, I think it's a bit the same as Adrien. So we start from really basic stuff. So how to define basic stuff. But if you know already one of compiled language or even some Python, normally you should not struggle to follow the lecture. How to say other? Yeah, for Eve, so it's C++ 20. It's a C++ 20 lecture, so you will learn practically another languages, but or again, if you know a bit of C++ or a bit of Rust, of Python, maybe Python is a bit far, but a bit of maybe C++ 11 or C++ 17, you will not get lost in this lecture. Maybe that's okay. For the GPU part, we'll start also from the beginning. So what is a GPU, how to use it, even if we already did that in the webinar, but we will do it again, of course, because it's important to have it in mind once you develop. And then normally, except that the vocabulary, because of course sometimes it's streaming multiprocessors, sometimes it's computing units, sometimes it's whatever. Normally you should be able to follow quite nicely all the lecture, because of course there is a lot of crossing between all the lectures, because we are talking about the same stuff, even if it's not totally the same technology. It's about GPU programming at the end, so normally you should not get lost. For the memory profiling or profiling, normally you should have a bit of knowledge of the system, but not too much, because Adrien and Sébastien will explain that to you on the fly during the webinar, during the seminar at the end of the day. So normally should be okay. And did I forget something, Adrien? Not sure.
No, it was just someone wondering a bit about the Rust course, so I explained a few extra.
Yeah, but for the lecture, I think normally should be okay. But yeah, we can have another. So for term normally it's already. Yeah, Karim did a well summary of that. Yeah, you need basically basic skill programming. Not necessarily in HPC, because we will teach you how to do that. But yeah, if you know a bit of how to compile, how to build, how to develop a bit, normally everything is fine after that. For a specific library, I think you have everything normally inside the container, so you don't hit internet, or you don't have to to have a good connection. Everything is embedded, so normally it should be okay.
I just discovered an issue with the GPU course on that, but we have some time to resolve it.
Okay.
As usual, it comes from the C side of things. Basically, I need some compiler for the GPU code, and if it's not already installed on the system, the build system will download and install it for you, and I did not catch that at the time, and I need to fix it. I will.
Yeah, but it will be done on time, so no problem. Okay. Yeah. So Tom, if you know C++ and Python, it's fine. You can, you will learn a lot of stuff starting with Rust. It's a really good language to have to criticize what you do in C++ and Python. In fact,
deconstruct.
Yeah, but it's interesting because you have the habit to do the thing in a certain way, and then Rust tell you no, you cannot, and you say okay, why? And then you realize, okay, it was not a good point because of that, and then you improve even your C++ way of doing stuff. So it's a good point.
Yeah, that's something I really try to do in the course, is to explain not only how things are, but why they are this way, because, you know, otherwise it can just feel arbitrary and different for the sake of being different.
And I don't want to spoil your lecture, but of course, when you are talking about Fortran, C++, or Python, they start once there were only one core in on a CPU. So what's the point to have a thread-safe API? And now Rust, of course, is designed to tackle this problem because it's a big problem now. So
it also helps some long-standing problems in all languages, like iterator invalidation, for example.
Yeah, the iterators are really powerful, but I will let you discover that in the lecture of Adrien because it's really, really powerful. Okay, so if you have not much question, maybe I can show you. So let's assume if I go here and I take maybe why not, so for example, not ARM images. Yeah, for ARM, because it takes an eternity to build. So if you need ARM images for code server, for example, just tell us because it's really long to build. So for now we have light images because they are mainly used with computing centers, all the satellite sites that are using ARM. So there is not much ARM images. But if you really need one for a code server because you have an ARM CPU, for example, if you are on Mac or something like that, maybe we can check. But even if container on Mac is not a super idea, but we can work on that. But yeah, for now we have mainly light images, and sometimes it's not possible. For example, in memory profiling, or I think also in profiling for the Adrien webinar, it's not possible really to use ARM because all the tools are designed for Intel and not really even for AMD. So
that's an issue. And another issue as well is that profiling tools are basically hostile to any form of virtualization, and this includes containers.
Yeah, so for this, they are not really lecture, but for these webinars, if you want to follow that on live on your laptop, maybe the bare metal installation is better. Even if normally for memory profiling, the container are working well, but for classic profiling,
I should have said I was talking about CPU profiling tools specifically, where
CPU is much more difficult. But for memory profiling, normally should be okay. All the images are okay, but for CPU profiling, it's quite difficult. And the same also for GPU profiling. If you can profile the images, for example, the images on NVC++ or CUDA or even Fortran, you can profile them with Insight because Insight is embedded inside the image. But you have to be careful with the permission that you give to your container inside your kernel. So by default, Aptener will make sure that you cannot do that. And if you have your kernel, you ask your kernel gently that, okay, it's fine, I want to be able to access all the metrics, it will be possible. For example, I think it was on Turpan, it's already the case. So they already manage that, so there is no problem. So that could be an issue, especially if you want to do that on your laptop. But on your laptop, typically you can install the HPC SDK. You will run it for C++ and for Fortran, and everything will be fine. So no problem. But no problem. But the HPC SDK on Ubuntu is something like 22 gigabytes, so you need to have a lot of space in your disk.
And also, this obviously assumes you have access to an NVIDIA GPU in your laptop.
And you need to have an NVIDIA GPU. The same for the cycle lecture. So it's mainly also for Intel and for NVIDIA. If you have another kind of GPU, it will be a bit difficult. And you also need, I think it's several gigabytes also for the images, because it's quite heavy. Every time we do some GPU stuff, it's quite heavy, except in Vulkan, because Vulkan is really, really light. But you should prepare yourself to have a lot of space, free space in your disk, if you want to get all the lectures. Otherwise, you will have a problem.
There's a question in the chat whether we need to be careful about specific CUDA versions.
It's a good question. CUDA normally is compatible with CUDA 12 point, I don't remember, but CUDA 12 something. Everything will be okay. I didn't try with 11.8 because we use the really latest HPC SDK, so the one, the 25.5, the one of last month. So okay, if you have CUDA 12, it's fine. No problem. I think we can have 12 point, I don't remember, 9 or no, 8 or 6, something like that. But any kind of 12 should be okay. And also, yes, if you want to use the GPU containers on ARM CPU with an NVIDIA GPU, I cannot check that because we don't have this kind of architecture here, but we can build the images for you. So normally it should be okay now, but yeah. And maybe if there is no question yet, I can get the opportunity to show you. So here, if I get my my Alpine Micro-Mbaku code server, so the image I get from, where are you? Here. So typically this one. If I get this one, if I start it with Aptainer, so Aptainer run, you bind the directory, because by default you will have some problem with Aptainer. It's a good point also. Please build. It's enough. And maybe, okay, yeah, you can have a writable TMPFS. So the point is, once you are using Aptainer, so everything is light, but you have some tricks involved here. So the point is, I have a build directory already here because I want to compile and to have space. The writable TMPFS allows you to modify a bit the images on the fly, but not too much. Normally, by default, you have 50 megabytes of modification possible. So to edit some sources or some compilation option is fine, but if you want, of course, to compile, it's not enough. So it's better to have a build directory, and if you do that, of course, you can compile, get back your result. If you change stuff, you can remember the stuff you change. And normally, if I do that, should be quite okay. Okay, so here I have a code server starting. If I click here, normally I have the same. Yeah, I have the same interface as on Jupyter, of course, on Must, because it's the same API. The images on Must is a bit bigger because we need to deal with proxies, with Jupyter proxies and stuff like this. But here it's okay. And then I get my README. Of course, I can jump on my lecture with the README, the same, exactly the same stuff. And as before, yeah, usually I mount in /build and not in build here, but you can, it's fine if I do that. No, I cannot because I already have one. So maybe I can, yeah, I already have a lot of stuff. So normally you should have already performances. I said before, just to not bother you with everything. But of course, I can say, okay, let's get rid of everything. Let's recompile. So with G++13, and I have only 24 cores, but it's enough to compile. And then I can compile. I can play with all the lecture, because mainly you will have to change parameters of program, not compiling lots of stuff. And then I can start my test, and as I did before, everything is will be fine. So it's working here. I use mainly Aptena because it's simpler for me, because I don't want to have a 5 kilometers command to start something. But of course, you can use in the documentation. I can show you. Here you have how to use images on a local server. So I just did, but you can also start with Podman, with Docker. You have all the information to start the same images. So normally you should not be lost, and you can do exactly the same on a remote server. So if you forward a port on SSH, you can start your code server in on the favorite server you want for the test, and then you get the port and you jump over it with your favorite browser. It's working. You can do that with a job also. It's working. So you can start a job with a code server and then jump on this server if you can forward the port. It's not, of course, if your node does not have internet, it's not possible, or doesn't have the network, it's not possible. If it's the case, you can. And then, so you have everything to submit some jobs. So with htcondor here, because we have htcondor at lab, but also with Slurm, you can use the Maisonette documentation here. So it's in French, but normally it's configuration, so it's quite okay to follow, and you can have all the information also to start Slurm jobs, so on the other satellite site, of course. And finally, you get the Jupyter here, a little demonstration of Jupyter. So I just did here with this one. So you can do the same, of course, but only this one is for the lab. But if you have the kind of the same environment, you can also copy paste practically everything, and it should be okay to follow the lecture. So another question from Tom, maybe a dumb question. I'm not used to containers, so by default I use Docker to be able to manage different containers inside my VS Code, but there is difference between Aptena, Docker, and Podman. Yes, it depends if you want something with a bit of bad faith or not, but you really want to ask that, Adrien?
I can provide my view of the situation, and then you correct me if you disagree.
Yeah, the short answer is they are all broken, but not the same way. So it's quite annoying.
Well, if we try to be a bit fair to each of them individually, basically Docker aims to be lighter weight virtual machine, so it aims for lots of isolation of the content by default.
Yeah, that's why you don't have internet by default in the container, which should be quite annoying if you want to forward port to jump on a code server.
You don't have inbound internet access, you have outbound, but Podman is a better implementation of Docker, essentially, which does not require you to run all your containers as a daemon running as the administrator user. So it makes very similar trade-offs otherwise. Whereas,
by the way, if you want to fix the problem of being root to start Docker, there is a good documentation on the official page of Docker, and you have a script, and normally should be quite okay
it's a bit of
use.
A mess, honestly.
Yeah, it's a bit of a mess, but
anyone to
it
use
worked
that.
for me once. So now I prefer to use Podman and Aptena, but it worked for me once, and now you are not obliged to be root to start Docker container, which is a good point.
And to complete the description, so Aptainer is quite different. Basically, it is HPC people looking at the app image software packages and thinking, oh yeah, this would be great if we could change this, and that. So it means that it aims for a lot less isolation by default. which is good in that you do not need to open access to the inside application before it can do stuff, but which is also bad because it means that the behavior of the container will depend more on which machine you are running it on.
Yeah, it's a bit annoying also, especially if you develop on the same machine and you want to run the same code on inside your container, because by default, typically Aptainer will mount your home, and maybe you don't want to have your home.
It will mount your home, it will run your bash profile, it will...
Yeah, and for example, with VS Code, with the code server application, if you say no home, and you start the container with no home, the code server will complain and say, oh no, I don't have my configuration, I don't want to start, because it doesn't use the right home, because you are you inside the Aptainer container, and you are not necessarily you inside another Docker or Podman container, and that's also annoying.
The way Aptainer is designed makes it basically impossible to install anything in the home directory of the container, which is a big problem because many modern installation tools are designed to operate in a home directory, since that's more convenient. It doesn't require administrative permissions.
Yeah. In fact, that's their goal. The point is, in Docker, you can do everything you want. You can even commit the images once you do some modification in it. And in Aptainer, they said, okay, no way. You change the images with a recipe, and that's it. And you are not allowed to change images in the other way. And the problem is, of course, they they change also stuff. Typically, the environment variable or the bash profile or the home in general, stuff like this, which is also quite annoying. Okay, yeah, Tom, you can also clone the repository. So, for example, in my lecture, normally you have a full correction here. Here you have the full TarGZ with everything. So all the code of the lecture, and then of course you have to have CMake, make a compiler, and gnuplot if you want to have the nice plot I showed you before also. And maybe also HWLock if you want to play a bit with that, even if I deactivated it yesterday to be compliant with other installation. Because sometimes if your kernel lies to HWLock, it will take it really badly. So I fixed that yesterday. You can get normally all the correction. For the Python lecture, it's a bit different because it's a notebook. So you can get also the notebook and play with it if you want. Maybe you can also rebuild the environment if you want, but it's quite big, especially for GPU. So you need to have space and time also to download everything. But it's possible. It's totally possible. And normally, yeah, maybe if you plan to take all the container in advance, which I can only recommend you to do, maybe in few days you will have some updates to do, but just in the lecture part or the example part, maybe with more details or stuff like this, but not the main layers that you will have for the installation, for example. So you could after that do a little pull, and then you get all just the modification of the layer you want, and not to get back all the images from zero. Because of course, if we find some little bug normally it should be quite okay, but it's possible also to have some fix to do, but normally not in the installation part, so you don't have to re-download everything. So should be quite smooth. And of course, if you want to follow the school a la carte, you will have much less container to download, but of course we will lose a lot of information because it's thought as a standalone school. Even if we have a lot of parts, all the parts are talking to each other, so it's much better to follow everything. Even if it's long, okay, but we have a lot of stuff to discuss, so it's normal.
Yeah, that's the most likely outcome.
In fact, next Monday we will not really need some images, except if you want to start the example of the compiler lecture. But
I think this might be the right place. I don't think we have the right person around for Fortran, but
yeah, Vincent is working on that. Normally should be ready today because now he has some time to do that. Normally, anyway, we will fix that this afternoon. Normally, at which hour I don't know, but normally it will at last it's for this afternoon. But yeah, basically, if you are able to start the C++ lecture, basically the Fortran lecture are based on the same images. They just had the Fortran compiler, so GFortran and VFortran on top of the images that I provide you. So normally should be okay. And maybe yeah, there is a stuff also for HDF5 to have the Fortran module for HDF5, which I don't have in my C++ lecture, of course, but that'd be too small changes, and you have all the common layer on top of that. So normally it will be quite small to get.
yeah, Theo, if you can maybe, at least for the C++, ask your questions. Maybe we can answer them right now.
The C++ GPU example are looking for GFR. I cannot find them.
Is this a local installation or container installation?
Yeah, normally inside the container I have HDF5. I forget that I think 2 weeks ago, something like that, 1 month ago. But now it's part of the image. So normally you should have everything.
Indeed, Mustafa, there is a container list. Maybe Pierre can post the link.
Yeah, I can get you the link here. If I do that, I put the link here. Normally you should be able to find. So yeah, on this page you have all the images of all the lecture. So we cannot provide all the lecture for ARM also because sometimes it's not possible because the lecture is not designed to work on ARM. But mostly, if it's possible, it does exist. So we have compiler, C++, cycle, Fortran, profiling, Rust, Python, EV, Kiwaku, and C++, NV, CUDA, etc. We have even a cubic square if you want, also like a cubic root. And then we have SQL on GPU. Yeah, only for Intel because it's really big. Intel and CUDA and Fortran, Rust, and Python on GPU. So, and yeah, when it's not precise, it's x86,
okay.
AMD64.
So Pierre, it looks like there might be an issue with the x86 and GPU container. There are several of those. I assume this might be the standard C++1 stdpar, where maybe it does not feature the HDF5 package.
x86 C++, normally it's...
The problem is that is ambiguous because we have several C++ courses and GPU courses.
Yeah, there is several courses for... Yeah, everything is split, but... normally there is the dependency inside the recipe at least. Maybe if you want, I can rebuild it just after the webinar, so you can have a look this afternoon. Normally should be okay, but I'm pretty sure that it's fixed because I fixed the two at the same time, so the ARM and the x86. And normally you should have everything in them. And yeah, of course, I forget to mention, but you can follow, at least for the C++ lecture, you can follow the CPU and GPU lecture if you get only the GPU, the GPU image. But it's big, so if you prefer to to have two of them, it's fine also. But you will get Macao, you will get HW lock, you will get TBB, you will get everything normally, even if in the GPU image. Okay, thank you, Theo. Yeah, maybe it's just my my CI because it takes an eternity to build the big. How to connect to Must? Okay, that's a good question. So on Must, so you have the link which is, I don't remember here. So this link here. So of course, if I jump, I have already a pod running, so I will connect automatically to my pod. That's also a good point if you want to have a pause and then you go back.
You can use private browsing as a hack for this sort of thing.
You
My
can
local
use
web developer told me this trick is so useful.
Yeah, you can use also. But basically, if you attend the lecture at lab, you will have an account on Must, and you will be able to connect with your account. But it's only for the people who join in ANSI. And the same, you have also documentation. Pass on it very quickly, but for the job submission, you get normally everything just to write your configuration to run on Must and to you jump on Must on with SSH. So I think yeah, you have an example here, really simple example, but basically you jump on Must. We will get you all the information just for people in ANSI because we don't want to bother everyone with that. But yeah, you will have everything to connect. And you will be able to start jobs and also to jump on the Kubernetes to run your lecture as I did here. And you can also, if you want, jump on Kubernetes, start your lecture, and do the same on your laptop to compare the performances if you want, with more core, with less core, with different amount of core and different specification. You can. Okay, thank you, Mustafa. So see you next week if I understand correctly. And okay, yeah, the same. All the point of where are the pause? Where do we have some lunch or something like that? We will brief you on time just in ANSI because we don't want to bother everyone with that. But yeah, we'll have all the information on time. Yeah, maybe I will rebuild my images anyway because there was an update of the HPC SDK yesterday, so. I think I will rebuild everything this afternoon, so everything will be aligned. And maybe a question for the chat. In the chat, did you already try to get some images and to find out how to use them? Okay, so for Luca it's okay, for Tom it's okay. Okay, so you mainly test. Okay, you should not test containers on Saturday, Tom. You should have a weekend normally, but yeah, okay. Yeah. Yeah, we are also some PhD students, so we understand.
You know, to teachers, the Fed weekend activities are finishing the courses, so I can understand.
Yeah. Or finishing the presentation, or polishing the slides, or in fact memorizing the slides because we have a lot of them. So yeah. Okay, if you have no more question, maybe Karim, Marie, you want to have something? Maybe we forget something?
I think we didn't forget anything. If there's no more questions, great. Of course, we are still here if you need any help. And so for you to know that we are also accept registrations, especially online, until the very end. So don't hesitate to.
Oh yeah, maybe it's a good point also. Yeah, for ANSI it's over because of course
it's full.
we have to, it's full. And for satellite site, maybe it's maybe the last day or something like that, because they have to prepare also something for the attendees. So if you want to be part of a satellite site, maybe don't wait also too much to register.
Yes, it will be tomorrow, the last day.
Yeah.
Really. Of course, so they can welcome you properly, of course. But of course, you know that even on satellite sites, you can attend the courses à la carte. So choose not mandatory the full 2 weeks, but some days that are interesting for you, such as online. But for any registration, any way you want to attend, you have to register through our website. So you can connect with our Discord channel and you can access the courses. If you don't register, it won't be possible. So please register. And of course, everything is free. And we just ask you to register for the organization.
And especially if you are a PhD student, you will get a certificate at the end of the school that you attend the school for this and this and these courses. So it could be also a nice point for the formation in the doctoral school.
Yes, good point.
It's mainly for PhD student, but or even if you are in graduated student, also you can normally follow a bit of lecture. Undergraduate, maybe it's not enough because it will be a bit hard, but PhD student, fine, graduated, fine. If you are an engineer or scientist, you can also follow lecture, no problem. It's for everyone.
Okay, so if there's no more questions, I think Pierre, we can close this webinar.
Yeah, we
Everyone?
have thanks in the chat. That's a good point to stop.
Yes. Thank you, Pierre. Thank you, Adrien, for all the inputs you brought today and the help. And we are very, very, very excited to welcome you all on Monday.
Monday 23rd.
Day 23rd. Yes.
No, not 24th.
No. 23rd.
Or at least it's not the same year,
of the
but do what you want, but normally it's next week, not
Well, enjoy the end of the week and see you next week.
Bye.
Thank you, everyone. Bye.
Bye.